Okay, yeah, we'll take a look at the documentation. So there are a number of, well, not that many, but there are a couple tools or libraries, adapters that allow Python to interact with Postgres, or Python to interact with MySQL, or whatever other database flavor you have, or whatever other language you have. So, if you're using Java or JavaScript or whatever, whatever you're using, probably there's going to be someone will or has written some kind of library that allows you to do SQL stuff, but in the given programming language that you're using. So psycopg is, we can install this with pip. It's a third-party module, so we do pip install psycopg, and then that gives us access to a bunch of classes and wrappers that allow us to interact with SQL. So we can populate databases, we can query databases, and then importantly, we can also get that information back as Python objects. So we can, for example, query a database in our Python application, and get the results, and then have that be usable within the rest of the Python application as strings or integers or whatever. So this is kind of a transitional thing. So we have SQL and then we have this, but the ultimate thing we're going to be using is Django, and Django has a slightly different, it's a more abstract API that you'll see later. So as I'm showing you this, don't think that, oh, I need to become an expert at psycopg and I need to learn all the, this library and all the methods and blah, blah, blah. This is just exposure. And yeah, so just try to get the basic concept. And then it's also an exercise in looking at the documentation. I want to do X. How can I figure out how to do X without becoming an expert in it? Okay. So we can look real quickly at the basic module usage. The documentation here is pretty good. So we have this import statement. So there's a couple of versions. There's actually recently psycopg2 came out. We're just going to use 2 for the sake of simplicity, but 3 is nothing that we're doing should be different. It's just some new features in 3. And the way it works is, if you just look quickly at this example, you can see that there's a lot of raw SQL here, right?
Excuse me, Chad.
Yeah.
Are you sharing VS Code or like something on a internet page?
I'm trying to share a browser, something in the web browser. Am I not doing that?
No, all I see is a VS
No.
Code application.
Oh man, sorry. Must have shared the wrong screen. And now I can't see. Oh man, I shared the wrong screen again. What am I doing? Okay, sorry about that. So let me just go back real quick. So here is the psycopg2 module here. Oops. So the docs are here, but you can easily do a search for psycopg or psycopg2 and pull this up eventually. So if we look at the basic, the basic documentation example here, we're importing this. We have to install it first. So we install it, then we import it, and then we have a bunch of raw SQL, right? So this particular library is not really it's not really abstracting SQL away from you. And when we get to Django, you'll see later that we're not really going to be writing SQL as such. We're going to use other functions and methods to do this, but here you still have to know SQL in order to use this. But what it does allow you to do is connect to a database and then do database operations. So there's a few steps. There's a little bit of boilerplate here. You have to create a connection to a database. So this assumes that a database exists. This database name called test. So you create a database connection, and then from that connection you have a cursor method. So psycopg2 is the basic, let's say the basic object here that has a method. So what does the connect method return?
A database connection.
Yeah, so it returns a database connection, which is itself an object, which has a method on it, right? So this has this cursor method. So you create a connection to the database, and then once you have a connection, you create a cursor, and then this cursor is also an object. So we have an object, we call a method on the object, it returns another object, we call a method on that object, which returns yet another object. And then once we have that, we have our cursor. So then we can execute the actual SQL that we want. And then you can execute it depending on what the state, if it's a create statement or something like that, then you're not going to want to do anything else. But if you're selecting, you can execute a select statement, and then you also have to execute a fetch statement. So there's a few more steps in SQL. You just kind of write it and that's it. Here we have to go through this boilerplate of creating a connection and then a cursor and then executing stuff. And then if we want to get results, we also have to call like fetch. There are a few, there's fetch many, fetch one, fetch all. But
Hey Chad,
yeah,
what's the purpose of the cursor? Just because I don't remember, like when we actually fill our tables using raw SQL, I don't actually remember having to make a cursor. So I guess I don't understand what's different here.
yeah. So this is, I mean, to a certain extent, this is just the API. One of the things that that you don't really see with databases is there are things called transactions. So for example, this is one of the benefits of using a database as opposed to just, a text file or something. But when you do an operation on a database, let's say like an insert statement or something like that, and it fails. Let's say you try to do an insert and the database can't do it, it fails for whatever reason. It will basically roll back. So it when it does an initial change, whatever changes you submit, it kind of packages it up as something called a transaction, and then it waits to see if that entire transaction succeeds. And if that entire transaction succeeds, then it will commit it. It actually becomes permanent. So that becomes like the new state of the database. If it fails, if any part of that transaction fails, it will basically undo that entire transaction. So even if a transaction has multiple steps, like updating multiple things or something like that, if it fails, it can roll back. So that's one reason to use a cursor, is to kind of make that more explicit. So this is a transaction that you're doing.
So transaction data, I guess, lives inside of the cursor.
Yeah, I mean, so yeah, so this is just an abstraction. So whether you think of it literally as a cursor or not, there's also seeking. You can do file seeking and stuff like that, which it's not entirely the same thing, but I would just think of this as you're establishing a connection. So now you have the ability to do something, and then a cursor is like a messenger. So you're kind of creating a messenger, and then when you execute it, you're actually telling the messenger to go do something. And then there's also this additional commit step. So some of this stuff is implicit when you're just using regular SQL. There are settings you can change, but it's stuff that is being handled automatically. And here, it's just more explicit. So you have to do an operation, and then if it succeeds, you can commit it, which makes it permanent, and then just like a file, you close those connections. So I guess the short answer is I wouldn't take it too seriously. I would just think of like, here are the steps that I have to go through in order to actually do something.
Yeah,
So you
roger
have
that.
to build up. So create connection, create a cursor, execute the statement, commit the statement, and then close the, step back down, close the cursor, and then close the connection. And you can see that this is, the steps involved are, it's more complicated, but it's similar to a file where we open a file, and then we do some operations, and then we close the file. So you kind of like step up, do some stuff, and then step back down. And when you do that, you can use a with statement, a context manager. So if whatever you're doing follows that pattern, you can basically implement the context manager API, which in Python involves writing an enter and exit dunder method, which we've seen before briefly. So I can see if I do a search for with, there's actually this with statement right here. So this is talking about transactions control. So if you're interested, you can read that. But this with statement kind of allows you to implicitly get rid of some of this boilerplate. So not all of it, but some of it. You scroll up here. So you create a connection, a cursor, and then execute it, and then commit it, and then close the cursor, and then close the connection. If you use a with statement, you can get rid of some of that. So here's an example. So we're creating that connection object in this context manager and giving it, assigning it to this name, con. And then from the connection object, we create this cursor object, again, within the context manager. And then once we have the cursor object, we can actually execute the SQL. And again, you don't need to become an expert in this. I wouldn't worry about it, but this context manager will automatically commit. So if there are no errors and this cursor block finishes, that it will automatically commit. So you don't have to explicitly commit it. What it doesn't do is close the connection. So you still have to close the actual connection. So here's an example of that here. So you can create a connection and then share it. You don't have to create a brand new connection every time you want to do something. So you can create a connection and then share it. So with the connection, and then create this cursor object, execute SQL, and then when this with block finishes, this will be automatically committed, so it'll be made permanent, and then so on. And then once you're done with the connection, then you have to close it. So the best way to do this is to wrap all of this in a try finally block. So you can create a connection, you put all this stuff, everything that you're doing, interacting with the database inside the try block, and then finally you make sure you close the connection. So that's the basic kind of structure of how you use this. So that's, even though there are, several steps, it's basically the same thing every time. So you create a connection, you create a cursor, you execute the cursor, and if you're using with statements, you don't need to worry about committing. Otherwise, you commit and then you close. So oftentimes, when you're working, especially with an application, you're going to want to have things be dynamic, or at least partially dynamic. So if I want to search for, I have my users database. So I want to get all users whose, account was created after 2012 or something like that. And I want to make that dynamic. So in my application, I want a user to be able to say, get me all the accounts after, and then have them select the date or something like that. So in order to make that, basically that means you can't completely hard code the query. You're going to need to be able to accept user input and incorporate that into your query. And you can do that. Let me see. So passing parameters to SQL queries. So here's an example. So we have an insert statement. So insert into a table, and then we have our columns, and then the values. This is going to be what we're inserting. So let's just say that this represents, in our application, we can have people create a new user or something like that, whatever this is. And they pass in those values. They pass in the values that are needed to create a new row in this database. So you grab those and you have to format it. So here's the approved safe way of doing that is you use %s. So these are all the values that you're going to get dynamically. And then as the second parameter to execute, you pass in either a tuple or an array of those values. So this would be like it's values 10, values whatever this date is, and then values of this string. So there's some more complicated stuff, but that's basically it. So there's this boilerplate about setting up connections and executing stuff, and then you have this formatted string in order to dynamically generate SQL. So that's pretty much all there is to it. That's all you need to worry about. And you don't need to memorize this. You can just look it up and use it, because after today, we're probably not going to see this again. Maybe a little bit, but are there any questions so far about this?
So we'll mostly be using Django to
Yeah,
interact with databases. So psycopg, this is just a way for us to see what Django's doing under the hood.
basically, yeah.
Okay.
Yeah. So it's a way, it's a couple things. One, it's a way for us to, for now, be able to use SQL in a Python application. And then later on, you'll be working at a higher level of booster. So this is kind of an intermediate level of abstraction. Just real quick. Let me just, let's see. So you don't get worried yet about this, but let me see. Where is the query stuff? Right. So here's an example of how you would search. So here's entry. So this is the table. You don't need to worry about this at all, but so your tables will become classes. So you'll write a class that will represent a table in Django. And then to query to get, this is like select star from entry where ID equals 1, basically. So there's no obvious SQL here. This is just, it looks like just, a method. But under the hood, Django is taking this, this is a high-level, it's translating this into something else, which gets translated into SQL eventually. So you don't need to worry about this, but this just to give you a preview. This is the kind of thing that you'll be doing later. Any other questions? Okay, so let's use this. We'll walk through an example. All right, so we'll zoom in here. So I know I'm gonna basically, I want to write a Python application that uses a database. So I'm not gonna do anything too involved, but so I'm gonna need psycopg2. I'm gonna have to install that, and I'm also gonna install Faker, the library that I've used before to generate some fake data. And you can just directly install pip install whatever, but that's usually not a good idea. It's best to create a virtual environment first, and then you activate the virtual environment, and then you install everything you need. So all the third-party modules are just local to this project. So to do that, so Python -m venv, and then I can call my virtual environment whatever I want. Call it myvenv. And it's going to do some magic, set up a bunch of stuff for us, which we don't need to worry about. And then I'm going to activate the virtual environment. So source, myvenv, bin, activate. If you're on Windows, it'll be slightly different. There's an activate script here, which I'm running, which you don't need to worry about. So I'm just basically gonna run that script. It's gonna set up my environment. So now it's kind of restricting anything that I install is just gonna stay here. Okay, so I'll do pip install psycopg2. And I don't know if this is psycopg2 or psycopg2, or I don't know exactly how to pronounce this, but so I'll install this. It's gonna take a minute. If you have issues, there's the potential for some issues here. So if you have problems installing this, just let me know. And then I'm also going to install Faker, pip install Faker. All right, so now I'm going to, oops. All right, I'm going to import it's like G2, and I'm also going to import Faker. All right, so if I just kind of follow the documentation, I'm going to wrap everything in a try finally. So try, I'm going to do some stuff. So here in the try block, I'm going to, I'll have a connection here, I'll create a connection, and then I'll try to do some stuff, and then I'll close the connection here. So I know I need a connection first just by following the docs. So I'm going to copy this. and then DB name test. So okay. So I've created a database called test, and I think this user is just going to be my like machine name, which is in my case code Platoon or whatever, code Platoon. So I should be able to create this connection, and then once I have the connection, I'm going to need to create a cursor object. So connection adheres to the context manager API. So with con as, I'll just call it C, although I don't have to alias it if I don't want to. And then from here, I can create the cursor. So once I have this cursor object, then I can execute my query. So in this case, I want to create a database. So I'll do cur.execute. And then here I can just pass in my string. So I'll do that here. SQL is indifferent to white space, so we can make this look kind of however we want. So I'm gonna create a table. So create table app users, something like that. And then I need to define the table here. So this is just normal SQL, but I have to write it as a string, which is a little inconvenient. And let's say it'll have an ID, which will be serial primary key. So we've seen that before. This is the auto incrementing unique identifier for every row. And then I'll do name, which is varchar, and I'll just keep it simple. We'll do salary or something just to get a number, and then integer. Okay, so I have this table, and so that should work. Let's take a look. So I'll run this file. So finally, so I've created this connection and then this cursor, and then it executes something, and then I need to commit it, but because it's in a with block, that's automatically taken care of for me by the API. So if this command doesn't throw an error, then it will automatically commit. And then finally, I want to close the connection. So con close. All right, so I'm going to run this file, Python, mydb. Okay, so looks like it ran. I can check and see if that table exists now. So PSQL can go in here, and it's called test and describe, and I can see that I have this app users table. So I've created a database, a SQL database, just using Python code. Okay, so it's not as simple. If this were just SQL, all you'd have to do is this part. But yeah, this gives us some other benefits. Okay, so I've created the table. So now what I would like to do as well is add some data. So I can do cur.execute. So I want to add a whole bunch of users. So I'm gonna just create a for loop and then do a whole bunch of insert statements. So for whatever in range 100, so I'll create 100 users, and I'll do name equals This is just going to generate a fake name for me, and then I think this is the correct thing. Okay, so I have my actual data, and I could have got this data from anywhere, from an application, from a form from a user, from JSON, from some API, wherever I get this from. Now I'm going to insert it. So cur.execute. I'm going to execute an insert statement. So I can do insert into app users, and then I will specify the columns here. So I don't do ID because Postgres takes care of that for me. So name and salary. And then values, I'll just do this on a new line. Values. And then for values, we could directly put this in or even use like an F string or something, but we don't do that for security reasons. So we'll use the documentation approved right here, like this. So the %s, %s, and we have two values we're going to insert. So %s, and this execute statement optionally takes a second parameter, which is going to be all the values that we want to basically inject here. So do a comma and then pass in a tuple, and that will be name and salary. If I make this smaller, is this still seeable by everyone? Okay. So I'm gonna get out of here and I'm gonna run this again. And I get an error. So what's the problem here?
Trying to create the same table again, but it already exists.
Yeah, exactly. So this should be familiar. This should be an error that's familiar to us from our previous experience with SQL. So I can create a whole new statement, or I'm just going to do drop table if it exists. And then run this again. I don't have that problem. And then I'm going to go into the database. So PSQL. I can describe the database, and I'm going to actually query. So I just want to do a quick sanity check to see, do I have 100? Do I have 100 rows in app users? How would I check if I have 100 rows?
You can select count of whatever.
Yep. So select count star from app users, and I have 100. So probably worked. I could look at the actual data, but I'm going to assume that this works. Okay, so now we have our data set up here. So we have our data set up. So now I want to write a query. So I'm just going to leave this here, and then I'm going to create a new file. So or maybe just app. And then I'm still going to import psycopg2. But now I have it's just whatever normal application this is. And I just happen to want to get some information from the database. So I'm just going to write a function here. So def actually, we could maybe make this a terminal. Yeah, okay. So let's just let's say we will write a function that will get user input, and then the user input will be a column, and then we'll just get all of the unique values in that column, something like that. So get column from, whoops, user. I'm not gonna wrap this up in a class or anything for now, but you can see it would be pretty easy, desirable just to start organizing this stuff. But okay, so get column from user. And we have two choices. We have, what is it, name and salary. I'm not going to do validity checking. I'm just going to roll with it here. Okay, and then I'm going to have a def run, which is going to execute get column from user. For now, I'll just print and then I'll run this. All right, so if I execute app.py, I enter a column, name, and name. Okay, so now we have kind of our user, the user input. This could come from anywhere, could come from somewhere else in our application or external or like a form in a web page, whatever. So we have this. So now what we want to do is actually query the database and get all of the whatever is being requested. So def get data, and this is going to take a column, and we're still going to do all the boilerplate here. So I'm going to do try, and I guess I'll create the connection here. So connection equals, and I'm just going to copy this line. So I create this connection, and then I do with com as c, and then I create a cursor, c dot cursor. Yes. So this cursor object, then I can actually execute it. So cur dot execute, and we'll figure out what we're going to do there. And then assuming that that goes well, it'll be committed, and ultimately we're going to want to return some kind of value here, but finally let's do okay, and then so what we want to execute is we're going to want to select everything, or select whatever this is. Actually, I'm actually not going to use a column. You can do that with it. It's a little bit more complicated, so I'm not going to do that. This will be not column, but maybe condition. Yeah, so I'll just do a condition. Sorry. So you can actually do that. The interpolation works a little bit differently. It's more complicated if you are selecting dynamically column names or table names. So I'm just gonna keep this simple. Condition. Here we go. We'll do select star from the table, which is going to be app users. And then where salary is, let's say, greater than, and then I'm going to dynamically insert whatever we have here. So we're going to get some salary amount, and we'll use that in our filter dynamically. Okay, and then I need to provide the value to inject here, which is going to be this condition, which is going to be really a salary amount. So, and the syntax for Python with tuples is if there's just one, you have to have a trailing comma. It's just how it is. So we have a trailing comma here. And okay. So we execute a select statement. And then unlike the other kind of table creation and modification stuff, we actually have to, in order to get it, we have to go through another step. So here we have execute the select, and then we have to do fetch. So I'm not going to do fetch one. There's a few fetches. Since we want multiple rows, potentially, I'll just do fetch all. So fetch all. And then I want to, let's just say I want to print the result. And I'm going to call get data with the condition. So let's see if this works. Enter salary amount, 5,000. And I guess there's a whole bunch of items. So let me bump that up a little bit. Run it again. Okay, so now I get fewer. So I get, we could go in and verify that this is working, but it looks pretty viable. Okay, so I got no one with that makes that much. Yeah, something like that. Okay, so we get a few, and we can see that we actually get the results that fetch all returns. This is a list of tuples. So the list is everything, and the tuple is each row. And we can see that we have this ID, which is an integer, and the name, which is a string, and then the salary, which is also an integer. So we preserve the data type as well. So if we wanted to do some manipulation there, we could write a for loop and then do some other stuff and use this elsewhere in our application. So that's the basic idea. So that's why we would kind of suffer through all of this extra boilerplate. It's in order to be able to use this data in the rest of our applications. So that's pretty much it. You guys know SQL and you know Python. So this is just one way of putting them together.
Chad, I have a quick question.
Yeah.
In your input from the user, is that available in the next method, the get data method, because it's just returned on line 7? So return COL. I'm just
yeah. So
that's okay. All right.
Yeah.
That's
So I'm grabbing whatever the user inputs. So hopefully that's a number, but I'm not checking it. It's actually just going to be a string. and then I'm returning it here. And then I'm just, because this returns a value, I'm just assigning it to this, and then
I
passing.
didn't. Okay, I didn't see that. Okay, that's the one part I was missing. Okay, thank you. Thank you.
So I just to do this quickly and kind of show what it looks like, I didn't package this up nicely in classes. It's just a script, but yeah, that's the idea. Okay, so yeah, so I'll stop recording here.